Alright, so symmetry. Symmetry means that you cut something in half, it looks the same on both sides, right? Fold it in half. So the graph that you see in front of you is symmetric about the y-axis. The blue part would lay on top of the red part if folded in half. The y values stay the same. The x values change signs. If that's ever the case, then it's symmetric about the y-axis. Okay? That works a lot better when you have paper out, sir. Okay? X-axis symmetry means if you fold it across the x-axis, it's going to lay on top of itself. In x-axis symmetry, the x values stay the same, and the y values just have opposite signs. That's it. That's all there is to symmetry. Okay? Make sense? Pretty simple. So this is basically saying the same thing. The graph of an equation is symmetric with respect to the y-axis. If you replace x with negative x, you get the same thing. It's symmetric about the x-axis. If you replace y with negative y, simplify and get what you started with. Yay, yay, yay. So we're going to test for symmetry with respect to the x-axis, these two problems. So to check for x-axis symmetry, we will change the y to negative y. And simplify. Can you do anything with that? Is there anything that you could do to simplify that?
Wait, why did you change the y to negative?
Because I'm checking for, when you check for x-axis symmetry, you change y to negative y to see if they're equal. Okay? So there's nothing that I can do to that. Absolutely nothing. Are these two equations the same?
No.
No. Because they're not symmetric, this is not symmetric. About the y-axis. Okay. Now let's do y-axis symmetry. To test for y-axis symmetry, you change the x's to negative x. So I have x squared. I'm going to change that x to a negative x. And that's going to be squared plus 4. Can that be simplified?
Yeah.
What is negative x times negative x?
X
squared.
It's x squared. So after simplifying this, I get y equals x squared plus 4. How does that compare with my original equation? They're exactly the same. So because they're exactly the same, this is symmetric about, that should be an X right there on my notes. I'm sorry, guys.
Yeah, I was gonna say something.
Then you should have.
Well, then I would just.
Okay. This is symmetric. About the y-axis. What does this graph look like if you were to graph y equals x squared plus 4?
A parabola
Parabola.
opening up.
Opening up,
Starting at 4,
shifted
4 to
up 4 units. Well, isn't the parent parabola symmetric about the y-axis?
Yes.
If I move it up 4, isn't it still symmetric about the y-axis?
Yes.
So that really makes sense. Part B. We'll check for x-axis symmetry. How do I check it for x-axis symmetry?
Turn
Turn the y into a negative y. So x equals negative y squared minus 3. Simplify.
X equals y squared minus 3.
X equals y squared minus 3. Are they the same?
Yes.
They're the same. So what's that tell us?
It's symmetric about the x-axis.
Okay. Best for y-axis symmetry?
Is it ever gonna be symmetric about both?
Yes, sir. And we'll talk about that in just a moment. So define y-axis symmetry. Replace x with negative x. Simplify. What can we do? Nothing. And our equations are different, so this is not symmetric about y. Pretty simple. Straightforward. Questions? Okay. There's C and D. Testing for symmetry with respect to the x-axis. Part C. X-axis symmetry. Replace y with negative y. Simplify. What do you get?
Symmetric.
You get the same thing you started with. I'm just going to write yes up here. I'm going to get a little lazy. Y-axis symmetry, replace the x with negative x. Simplify. And what do we find out? It is also symmetric about the y-axis. How can a graph be symmetric about both?
Second.
It's a circle.
This one is a circle. This one is a circle. It doesn't have to be a circle, an oval would do the same thing, okay? But this one is a circle, okay? And the radius of that circle, by the way, is 4. I can tell by looking at it that the radius of that circle is 4. Any idea where the 4 came from?
The square root of the 16.
Square root of 16. That's exactly right. The equation of a circle is x squared plus y squared equals r squared. Something extra thrown in there. Okay. Part D. Replace the y with negative y. 2x plus negative y equals 4. Clean it up. 2x minus y equals 4. Are they the same?
No.
Is there symmetry about the x-axis? Okay. And for y-axis, 2 times negative x plus y equals 4. Negative 2x plus y equals 4. What do you find out there?
Not symmetric.
Not symmetric there either. Okay, so we saw 4 different problems. One was symmetric about x, one was symmetric about y, one was symmetric about both, and one's not symmetric at all. No other options, right? Any questions on this symmetry? Here's another symmetry. A function or graph can be symmetric with respect to the origin. So instead of being reflective or symmetric about a line, it's going to be symmetric about a point. So this is kind of a different concept here. So find out if it's symmetric about the origin, you replace x with negative x, and you replace y with negative y, both at the same time. And if both of them plugged in at the same time come back as the same equation, then yes, it has symmetry about the origin. What about that circle? If we plugged x in, we found out it worked. If we plugged y in, it worked. Is a circle that has the center at the origin going to be symmetric about that point? Yeah. Yeah. Okay? And so the way that looks would be, so we're going to check symmetry about the origin. So we're not looking at a line now, we're looking at, is it symmetric about the origin? Which means x becomes negative x, and y becomes negative y equals 16. Simplify all of that, and you get x squared plus y squared equals 16. So yes, this is definitely symmetric about the origin. I'm going to write the same thing again. I don't want to do that. How about part B? Replace y with negative y. Replace x with negative x. And simplify. Left side is just negative y. The right side, we have negative x times negative x.
Positive
That would be positive x squared.
Makes it negative again.
Times negative x makes it
Negative.
a negative x cubed. Can I simplify further? How? Divide by negative 1, or multiply by negative 1. If I multiply an equation by negative 1, or divide by negative 1, it's not going to change the value of the equation, because I'm doing the same thing to both sides. It might make it look different, but it's the same equation. I like to do it as multiplying. If I multiply by negative 1, what's that going to do?
Change out all the signs.
Change the signs. So it becomes y equals x cubed. Did I end up with the same thing I started with? Yes. This function is symmetric about the origin.
Wait, how?
Because these two things are equal.
Yeah, but how'd you get there again?
Okay? So I changed the y to negative y and the x to negative x.
Yeah.
Nothing to do with negative y, so it's still negative y. Negative x to the third power would be negative x times negative x times negative x, which is negative x cubed. Okay? If I multiply that equation by negative 1, I'm just changing the way it looks, not the value of it. So that negative becomes positive, and that negative becomes positive. And now I've got exactly what I started with.
Okay.
Okay?
Yeah.
Any other questions? Okay. So here's a quick summary of what we just talked about. If you replace y with negative y and you get the same result, then it's symmetric about the x-axis, and you have an example of that picture there, that little oval that's been shifted over. If you replace x with negative x, you can see symmetric about the y-axis. And that last one, that's what the graph of y equals x cubed looks like, isn't it? And so this might not be to scale. So see how this works. If this is, let's say that this equation is y equals x cubed. Okay? If I chose an x value of 2, it has a y value here. What is that coordinate?
8.
2 comma what?
8.
8. Because I plugged a 2 in here, 2 cubed is 8. Right? What if I came over here to negative 2? What is that coordinate?
Negative 8.
Negative 2, negative 8. So you can clearly see that the point xy is on that graph, and the point negative x, negative y is also on that graph. If that is true, that makes it symmetric about the origin. Okay? Any questions on this? Okay. Even and odd functions, folks, this right here is a super important concept. You're going to see this in pre-cal next year. It's not going away. You need to understand what an even and an odd function is and how to determine if a function is even or odd. Okay? I'm going to give you a couple that I know. They're very, very basic equations that I know. I've got one that's even and one that's odd. Okay? Here's an example of an even function. Let me say that f of x is x squared. I know that that's an even function. Y'all agree that's an even function? It's symmetric about the y-axis. It's a parabola. It opens up. Vertex is at the origin. To verify that this is an even function, what I'm going to do is I'm going to replace the x with negative x. So here's my function. I'm going to take that function. I'm going to plug in negative x. When I change x to negative x, that gives me negative x squared. And what is negative x squared? X squared. So look what just happened here. F of x is x squared. F of negative x is also x squared, which means f of x equals f of negative x. Right? Yes? No? Do you remember a property in mathematics about that? Do you remember something called the transitive property?
Oh, yeah.
The transitive property says that if A equals B and B equals C, then A equals C, right? If f of x equals x squared, but x squared equals f of negative x, then f of x equals f of negative x. Right? Transitive property. So this leads to the fact that f of negative x does in fact equal f of x. A function is an odd function if f of negative x is equal to negative f of x. What the heck just happened there? So here's an example. Change to red here. Here's an example of an odd function. 6A, you stand up? You need to stand up? Okay. F of x equals x cubed. That's an odd function. Well, what happens when I plug in negative x? That gives me negative x cubed. What is negative x cubed?
Negative x.
Negative x cubed.
Okay? Is x cubed the opposite of negative x cubed?
Yes.
Okay, so because x cubed is the opposite of negative x cubed, then f of negative x is equal to negative f of x. It's odd. Any questions on this concept? Okay. No questions? Diego, you all right?
Yes, sir.
Can I stop you around? I didn't hear you falling asleep, huh?
It's cold.
Okay, so we're gonna have several functions, and our goal is to determine whether these functions are even, odd, or neither. And to find out, all you do is plug in negative x. Okay? Plugging in negative x gives me 8 times negative x to the 4th power minus 3 times negative x squared plus 1. Let's simplify that. Negative x to the 4th power,
8x. No, 8
X to the
4.
x to the 4th times 8, so 8 x to the 4th. Negative x squared,
X squared.
x squared times negative 3,
Negative 3x squared.
and there's that plus 1. So what do you see?
It's the same.
Okay, so we just found out that f of x is in fact equal to f of negative x. And by definition, that means this function is
Even.
even function. Someone say I don't get it?
So can it be even and odd?
Can a function be even and odd? Can you think of a number that's even and odd? Okay.
Wait, no, that really fast.
Huh?
You did that really fast. Me too. Well.
Wait.
I can't write the right things.
You can't what?
My pencil's not letting me write the right thing.
Well, get the lead out.
It's not working.
That was a good double meaning.
I didn't get it at all.
Whatever.
I was kind of a dad joke.
Get the lead out, you're slow. The lead out, you need to speed up.
That's
Your
like
pencil's
ketchup.
not working, get the lead out. It's gonna work better when I have lead out. If you're writing with actually it's
It was
graphite.
definitely a dad joke.
Are you done yet? Okay, moving on. Screenshot it, I've waited too long.
Okay.
Next function. F of x equals 6x cubed minus 9x. To determine if a function is even or odd, all you do, plug in negative x. So what is f of negative x? Well, that'd be 6 times negative x cubed minus 9 times
Oh, okay.
negative x.
I just think I zoned out or something, because I didn't hear him say negative X the first time, I kept, I answered it with right at the top.
Yeah, I'm having major selective hearing in this class right now, and I don't know why.
And then it's negative 6x cubed.
Okay, so negative x cubed
Negative X cubed.
would be negative x cubed. Negative x cubed times 6,
-6.
negative 6x cubed. Negative 9 times negative x
Plus 9x.
plus 9x. How does my answer for f of negative x compare to f of x?
Polar opposite.
They're total opposites, right? All the signs changed, which means that
It's neither.
f of negative x is the same thing as the opposite of f of x.
That's a ton.
So if I took this first function, if I multiplied this equation by -1, I would have negative f of x equals negative 6x cubed plus 9x. Is that what I got?
Yes.
Yes. So because f of negative x is equal to negative f of x, this is odd function.
Okay.
Okay? So again, we're going back a slide. If f of x and if f of x and f of negative x are equal, then it's even.
Wait, but the other ones aren't equal though, because.
But if f of negative x is equal to negative or the opposite of f of x, then it's odd.
So the signs are all opposite and it's
All signs, every one of them,
is odd.
then it's odd.
What if one of them's just different? What
It's
happens
neither.
if
Neither?
Are they the same if one's different?
no?
Are they all different if only some?
Oh,
What?
I'm so confused.
No.
What if
So I just
someone
like
like
reading
an
that.
x cubed and x squared?
Okay, let's do this one.
Okay.
Wait, I don't have enough paper. I lose the last one. I'll just put it right here. Actually.
I like that.
I want to know if f of x equals 3x squared plus 5x
So
is
there's
even,
and neither.
odd, or neither.
No. I have enough space. Oh. Yeah, I'm keeping that actually.
Okay, well, to test, we plug in negative x, which gives me 3 times negative x squared plus 5 times negative x.
You're right, really
So
fast.
it's neither.
It's because it's
Because you get
negative
negative 3, you get
3x.
positive 3x.
Oh yeah, 3x
You
squared.
get 3x squared plus
Minus-
negative 5x.
No, it's
Or minus. Yeah. It's the same thing.
it's not the
Yes,
same.
it is.
Okay,
It is the same thing.
so if I have a negative x and I square it, I get
Positive x.
positive x squared.
But you could
And x squared times 3 is, 3x squared. So as of right now, they're looking the same. As of right now, it appears that this might be even,
No.
okay? But now I have 5 times negative x
Negative 5x.
-5.
minus 5.
minus 5x,
Negative.
okay?
Wait, I have to settle this.
So it's
question.
even.
If you add negative 5x.
No,
not
it's
the same.
neither. No, it's
Yes.
even.
What? It's
I'm
not.
so confused.
Because one of them isn't the same.
It's
Not
neither.
one of them isn't
No,
the
no,
same.
it's
Not
a
all of
string
them. So it's
matter.
not odd. And then both. It's not all the same. So it's not even.
Correct.
It's either all same or all different.
This is too
Between it's not.
confusing.
I'm just learning.
So-
I can understand. I promise you.
Even or odd? Or neither?
Neither.
Neither.
Okay.
Odd one
That
out.
went way too in depth for a neither.
Okay.
know, like,
So again, let's go back. Look at these one more time.
Oh, that's
Okay. Okay, Tyler Zivit. If the function f of x is equal to the same function when you plug in a negative x, if you get the exact same thing, if you get the exact same thing you started with, it's even. Okay? Please quit talking. Please quit talking, I'm recording. If you plug in negative x and you get the total opposite of what you started, meaning every single sign is different. Be careful with your signs, okay? But if every single sign is different, then it's odd. Okay? They're all the same, even. Opposite signs, all of them, odd.
So wait, when you put the negative in front of the f of x, that's just saying it's the opposite.
It's the opposite of f of x.
Okay.
Yes, that's one way, I like reading it that way sometimes because it makes more sense. Okay? If, however, you plug in negative x and you don't get the exact same thing, and you don't get the total opposite, the 5x and negative 5x, those are opposites, but 3x squared and 3x squared are the same. So they didn't all change. It's neither. Yes?
Wait, so how would you write, like on the other ones you wrote, f of negative x equals negative f of x, how would you write that?
For this,
Yes.
there's nothing to write.
Oh,
You can say not equal to if you wanted to.
oh,
Okay? Yeah. Other questions? Did anybody notice anything as we worked those three problems?
Like each one had its own.
Were they the same?
Look at the exponents.
Oh, the odd.
If it's odd exponents, then it's odd. If it's
what?
even exponents, it's even.
oh, I didn't.
Oh.
Is that actually a thing?
That the even had even
Well, it's neither,
exponents,
then
odd
there.
had odd.
So I can just cheat.
Okay, so this one was odd. And what are the exponents on the variables?
3 and
They
1.
are
3 and 1. They're both.
Odd.
Numbers.
This function is.
Odd.
You're telling me I didn't have to work it.
Yeah.
Okay, hold on.
Wait, I'm confused.
Even and even.
Even.
Oh no, I get it.
But what about that 1?
Doesn't have
There's
some-
no
It has an
There's
exponent.
no
It's
exponent.
zero.
It has an x.
No.
It's a zero.
It does not have an
It does. It has x to the 0 power.
Tyler.
And
What?
0 is even.
Okay? Yes. Folks, if there is a constant, that term is even. I don't care if it's a 1. That term is even. Because it's x to the 0 power. Okay?
Wait,
Which means, is this function even, odd, or neither?
Neither.
Neither, because this one has an even exponent.
That's what I was thinking.
wait, so
Okay.
zeros even?
No,
But
if
zero
it's
is
there's an
even.
even or even oh my gosh, I'm brain farting.
Sir, we're sophisticated, it's called cranioflatulence.
I'm sorry. What did you say?
What?
Cranial
Flash?
We are sophisticated.
So-
I understand the
Brain
second word.
fart.
I make jokes with that word. What is the first
It's
word?
a brain
Cranial.
fart.
I understand your
English
confusion
to me.
about knowing what cranial
You don't
is.
know
Speak English.
cranium, like.
Cranial's the brain, sir. I understand you don't understand what cranial is. I got it. I'm with
I
you.
think everyone else was confused with the last word.
I know.
Lactose, I used to make jokes about that. in middle school.
Okay, here's the next slide. If the function has only even exponents on x, including the case of a constant where x to the 0 is understood to have an even exponent 0, it will always be an even function.
How is it this slide at the beginning?
Similarly, if only odd exponents appear on x, the function will be an odd function.
Because you didn't want to show us the shortcut
Okay.
after you made us do the long one.
I noticed it right at the
Okay.
Gross. I don't have a
Oh,
All right, here we go. We're gonna do some transformations.
No.
Wait, 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 wait,
I don't
wait,
get it. How
really
do we-
quickly,
I know
we
how
read
to do
something.
it.
If the function has only.
We're going to graph g of x, which is equal to the absolute value of x minus 4, and compare it with the graph of the parent function. I'm going to call the parent function f of x. And what is the parent function of g of x?
absolute value of x.
Absolute value of x. And what does the graph of the absolute value of x look like? Looks like a V with the vertex at
-4.
at 0. I'm graphing this one right now,
Okay, alright.
okay? So if I was going to graph this parent function, it looks like this.
Yeah, it looks like that.
Oh,
Stop
it's
it.
like that too.
Yeah,
That-
just-
that looks
just the line.
smart.
And it looks like this. That's the wrong color.
Having a rough day.
And the arrow on the wrong end. Here's two.
Yeah, it was at 0, 0.
Looky there,
Finally.
okay? Yeah, okay, fine. We'll do this one and we'll go backwards. I got you. Okay, so that's the absolute value function. Okay?
My eyes get so trippy when I look at that board for too long.
So what are we doing here? I'm taking the function
And,
and subtracting 4 from it.
you're putting like,
Isn't
You're,
that
yeah,
going
you're
to?
shifting it vertically.
yeah, no, is it?
Yeah, it's,
Oh, JK, it's going this way.
You're moving it down.
Okay?
It's negative.
I'm moving it down 4 units.
Oh, we're gonna try this again.
Oh.
Shh.
But
Okay,
it's
that
like
line
a
is
person,
perfectly
right?
straight.
It's squiggly.
It's perfectly straight. So what did that -4 do?
Yeah, bumped it down.
Translates
That's what the word is. I kept thinking transform.
4 units down. Okay? Pretty simple.
I think the blue lines are better.
Yeah, me
The
too.
blue lines are pretty straight.
Here's the graph of the parent function. That's just all it's translates for you.
That's just the comparison. What is the comparison? The red graph is 4 units lower than the blue function, right?
Yeah.
So here's the general properties of a vertical translation. This blue graph here in the middle represents some random graph. If I take that random graph and add 2 to it, it's going to shift the graph. It looks exactly the same, but it's 2 units up. If I take that original function and subtract 3 from it, it's going to be the exact same function translated 3 units up. Okay? Vertical translations are very, very, very simple. Okay? And we will continue from here tomorrow.
What?
I said
I already
brain,
did
not
7.
skull, by the way.
Take that out.